In this video, I want to talk a little bit about the energy requirements of translation. So in translation, we had a bunch of different processes occur, namely initiation, elongation, and termination. But before we could even have that, we had to have the amino-acyl tRNA synthetase reaction occur, which activated the amino acid and charged the tRNA. So each activation step, or charging step, requires 2 ATP equivalents. And that's because we went from an ATP to an AMP and a pyrophosphate, and of course the pyrophosphate was hydrolyzed off into 2 inorganic phosphates. So that's the equivalent of using 2 ATPs. Initiation required 1 ATP equivalent, in which we used a GDP, which was hydrolyzed off into a GDP and an inorganic phosphate. The elongation required 2 ATP equivalents. There was 1 GTP for the actual elongation step, in which we formed the covalent bond between the 2 amino acids, and 1 GTP required for translocation. So now each elongation step required 2 ATP equivalents. So each time you add an amino acid, it costs 2 ATP equivalents. Termination required 1 ATP equivalent. A GTP was hydrolyzed off into a GDP and an inorganic phosphate. So if we know this information, how can we use that to calculate the amount of energy it would cost to make a peptide chain? So what if we wanted to make an amino acid chain of just 4 amino acids, a peptide chain made up of 4 amino acids? How much energy would that cost? Well, each one of these amino acids needs to be activated. So that would, we have 4 of them times 2 ATP equivalents, because each step will require 2 ATP equivalents. Initiation only needs to happen once, right? Once we've initiated, we're done. So we require 1 ATP equivalent for initiation. Now what about elongation? Well, once we've initiated it, we have 1 amino acid sitting in the peptide chain, and we're going to add 3 to it. So that means if we're going to add 3 of them, then we're going to have 3 elongation steps. So we're going to have 3 elongation steps times the energy requirement for each step, which is 2 equivalents, so that'll cost us 6 ATP. Once we've added all of those, we need to terminate the translation, and that's only going to cost us 1 ATP equivalent. So that total there is 16 ATP. So what about for a peptide chain that with 30 amino acids in length? Well, in this case, you would have to have 30 times 2 for activation. Each amino acid would need to be activated, so that would be 60 ATP there. Initiation only would cost 1 ATP. Termination would also only cost 1 ATP. In this case, how many elongation steps are we going to have? Well, if it's 30, we start off with 1 amino acid, and we're going to elongate it by adding 29 amino acids. So we're going to have 29 times 2, which is 58. So then if we add all this up to get to total, we get 120 ATP. So that's how much energy would cost to make a peptide chain that was 30 amino acids in length. Hope that video was helpful. One last thing, I am a tutor. If you live in Southern California, feel free to contact me via email at moofuniversity@gmail.com. See the description below for more details. Thank you for watching.